What's up guys? LeetCode 200 number of islands. Given a 2D grid map of ones and zeros, count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So example 1 and example 2 is showing us a grid n by n, and here we have one island and three islands. So the text is saying us that an island is a group of ones surrounded by water, and the ones should be connected by another one. Okay, so an island is any group of ones that is connected like this. So this one here is connected with this, and it's connected with this, and so on. Let's see the example 2. We have an island here, another island here, another island here. Okay, so this seems to be a classical depth first search algorithm, which we need to get through all the lines and columns of this grid, checking if the current value is 1, which means is a piece of land. And if we get 1, we need to call a depth first search function to actually get the job done. And this job would be checking all the four edges of this column. Like here, if we are here in the line 1, column 1, we find 1, the value 1. We need to check this column, this column, this column, and this column. And we can do this easy with recursion using depth first search. Yes. So the only thing that we need to care about here is if we get out of bounds. I mean, if we are here, we need to care if we get on the next column which doesn't exist. And we also need to care about if, imagine we start here and we get here. Our recursion will try to get here again, but this is a value that we have already computed. So yes, we need just to, when we get here or whatever column that has a value 1, we need to change its value to anything that is not 1, because that will prevent us to get into an infinite loop. Yes. And I think this is most of this solution. We can write a bit of code and try to see if we have to care about any other thing. Even if the exercise is not same, it's always good to check if our input is a valid input. And like here, we can check if grid.length is equals to 0. If yes, we just return 0, because if we don't have any water or land, we will not have any island. Okay, so let's code our for loops. So line here, which will go through all the lines of the grid and also the columns. As the lines or columns need to go through all the columns in each line to get the length of a line. We just need to get the length of a specific line here and increment. So okay, with this code here, we will iterate through all these. We will iterate in all the grid, in all the lines and columns. So first thing we need to check here if our current value of this line and column is 1, because if it is 1 means that we find a piece of land and means that we find an island and we need to compute. So I will create a variable here called result, and the result will be incremented here because we just found an island. And here we will have the work done by a depth first search function. After we get out of this for loop, we just have to return our result. Okay, so I just write this calling here with no parameters because I don't know yet which information I will need inside this function. So let's try to code it. I think this will be a void function because I actually don't need to return anything. I will just update the value of ones here to 0. Yes, so by now it seems that we don't need to return anything. Okay, let's put the parameters here because I think we will need our grid and the information of line and column. Okay, so let's code the update value because we can't forget this, like the current column must be set to 0 because if we get in this part of the code means that the value of this column here is 1 and we don't want to get in an infinite loop as I said before, so we just check this to 0. And also, as this is a recursion, we need to care about our base case because again, as this is a recursion, we don't want to get an infinite loop. So let's check first if we are out of bounds. So if our line is less than 0 or if the line is greater than the grid dot length. Same thing for the column. If the column is less than 0 or if the column is greater, it's actually greater or equal to the current line of this grid. I think that's it. If any of these checkings here returns me true, I will interrupt this execution and the next execution on the stack will start. And to the next execution start, I first need to put it on the stack. And now we start our recursion here. So let's see this example. If we are here, we need to call the DFS function with to check this column, to check this column, to check this column, to check this column. So okay, so as we already have the information of the line here, I just need to get one column forward. So I can do this by call +1. I will need to do the same for the column backwards. I can do this, just decrement the value of the column, and I will do the same thing for the line. So I need to get this line here and this line here in the same column. So I will do first the line +1 with this column here, and also the line -1. So I hope I hope this is clear for you because I'm just getting here and call our function to check this column, this column, this column, and this column using the information that I already have here. Uh, okay, so as we are also updating the value here to 0, we don't care about 0 values. So we can just ignore 0 values here by doing this check. So if also the value is 0, I can stop this execution. Let's just give a second thing here. Okay, so our DCS function seems to be like this, and we can just pass our parameters here. So we need the grid, we need the line, which is the I value here, and we need the column, which is the J value. Okay, so if we don't have any typo or any mistake in our logic, I think that's the solution for this problem. Let's check. Okay, so we get accepted for this parameter here. We can, would be a lot of work to test this. I will just hit submit and let's see what happens. Okay, so that's it.